Tiger Woods, professional golfer, hits his driver 320 yards. At impact with the golf ball, he creates a launch angle that starts ball flight at 32 degrees. His ball travels 154 yards until it reaches its apex. Find the distance on the ground from impact to when the ball reaches its apex, and round to the nearest whole number. So to solve this problem, we're going to need to use cosine. So to do that, we need to find the adjacent and the hypotenuse. So we're going to set it up in this format, a over h. So it will be x over 154. And then after we find that, then to put it in our calculator, we'll need to say 154 times cosine times 32, which is your launch angle. And then once you type that in and hit enter, you should get 131 yards after rounding to your nearest whole number.
Jason is putting a new roof on his house. The length is 36 and the angle is 45 on the left of the roof. What is the height of the roof? So we're using tan. So you guys have to put O over A. You have to identify where each angle is. So A is always closest to the angle, and X is always opposite. O is always opposite of the angle. So you'll put down 10, 45 equals X over 36. And you have to times it by 36. So if you're doing this side, you have to do it to the other side. You go to the other side, 36, 10, 45 equals, and after you put it in the calculator, it'll give you 36.
Boom.
Alright, so today we're going to be talking about using the inverse trigonometric function. So here's my word problem. Tracy is making a scale model of the Angus McDonald Bridge. She knows the distance of the sides, but she wants to find the suspension and lift angle. Use the inverse trig function to find the angles and round to the nearest whole number. So this on triangle 1 is the suspension angle, and this over here on triangle 2 is the lift angle. And so in order to find that, you would need to know the opposite and the adjacent because we're going to be using the inverse of tan. So this section right here is called the lower rail section, and this section over here is the vertical bar, and this section here is the angled bar. So when using the skills that we know, 350 would be adjacent to the suspension angle, and the vertical bar, which is 169 feet, that would be the opposite. So moving on to triangle 2, this is the angled bar. This 260 feet is called the upper rail section, and this 169 feet is also called the vertical bar. So using the skills that we know, if you're going from the angle, the 260 would be the opposite, and the 169 would be the adjacent. So next, we're going to draw out the triangles separately and solve. Alright, so here is triangle 1. Let's solve this one. Here, we have to draw, this is a right triangle, so we always draw the little square. 169 feet is the length for the vertical bar, and this is the suspension angle, and the lower rail section is 350 feet. So since we're using tan, and let's call this x, we would do x is equal to the inverse of tangent And then we would have to, this is our opposite, and this is our adjacent. So we would do 169 over 350. And when you plug that into your calculator, you should get 26 degrees. All right, let's solve triangle number 2. So, the second triangle is drawn a little bit differently, and you always have to draw your little square because it is a right triangle. The vertical bar is 169 feet, and the upper rail section is 260 feet. And this right here is your lift angle, and we're going to call this Y. So we're going to write Y is equal to the inverse of tangent, and if you go from your angle here, 260 would be the opposite, and 169 would be the adjacent. So we're going to do 260 over 169. And when you put that into your calculator, you should get 57 degrees.
Has an oak tree in his backyard. He wants to know the angle from the top of the tree to the top of the shade. The tree is 11 feet tall, and the length from the top of the tree to the top of the shade is 19 feet. What is the angle? Round to the nearest whole number. So here, our equation is sine opposite over hypotenuse. We will set this up as sine W, and our opposite angle is 11. So 11 over 19. But then there is no angle, so we must put sine 11 over 19. Oh no. Equals W, and our answer is 35 degrees equals W.